Hello students, welcome to the iRobot Automation YouTube channel. In this video, I am going to demonstrate the sequencing of multiple actuators, in particular multiple cylinders. Okay. So this is what I am talking about now. From project 1 and project 2, we discussed the circuit with only one cylinder. Okay. But here we are talking about multiple cylinders. Actually, this application is pneumatic, but still, anyhow, we'll consider it for hydraulic circuit also. Assume that there is application, that means there are two conveyor belts. There is height difference is there. So there is a metal transportation from one conveyor belt to another conveyor belt. So there is a Z1 cylinder and Z2 cylinder. Here, Z1 cylinder we call it as A, cylinder A. Okay. So, and Z2 cylinder we call it as cylinder B. Okay. If you want in particular, you can also say that is Z1 plus, because the component which comes from lower conveyor belt sits on the Z1 cylinder, and Z1 cylinder first it will move upward, and next Z2 cylinder plus means second cylinder will push the component by moving forward. Next is Z1 minus and Z2 minus. This is what they require sequence. Once we get the one cycle, then it is required to be repeated for many cycles. Okay. So let us discuss first how to get one cycle of sequences. Next we will discuss how to automate it for repeated cycles. Okay. Now since our topic is hydraulics, so let us open FluidSim hydraulics, and here, so there are two cylinders are there, right? This is a multiple cylinder. There are two cylinders are there. So I am going to take two double acting cylinders. And solenoid operated valve, that is to control each cylinder direction. One direction control is required for each cylinder, and pump unit can be only one, no need to take two pump units. And to control the speed or the velocity of the cylinder, I require a throttle valve. Throttle valve I require in two quantity. Okay. So start connecting. And P to P. So here also P is there. And piston chamber to A, rod chamber to B. Here 1T. It is overlapping, so it is not good actually. T, and P should be connected to P. One more T is left, that should be connected to tank. Okay. So now the question is, see, cylinder, this is cylinder A and cylinder B. cylinder A, this is cylinder A, and this is cylinder B. So in automation, event, when event completed or not, so that is very important, right? Here event means when cylinder completes forward stroke complete, then forward stroke is completed. So meaning that forward stroke event is completed. To know whether cylinder completed full stroke or not, we should have sensor. Okay, like that, whether cylinder A retracted or not, that is the question. For that, we going to place a sensor. So with the help of sensors, we get to know whether cylinder is extended or retracted, right? That means each cylinder should have two sensors. So to have a sensors on the circuit, double click on the cylinder, and in the parameter note down what is the cylinder stroke. Maximum stroke here is 200 mm. Okay. Now go to the actuating labels. There you add A0. A0 is a sensor which is placed at the retracted position, means starting position. What is the position? I am placing it 0 mm, means starting position. A1 means at the end of the stroke, that is 200 mm we are placing it. See here, I am going to place here, drag and drop here. A0 is, if A0 is on means cylinder is retracted, means starting position. If A1 is on means cylinder is extended, means forward movement is completed. Okay, so I am going to, so here forward movement can also be like this, extension we call it as. Backward movement, retraction. Okay, so these words we use it. Like that, cylinder B also, double click on it. Parameter, that is 200 mm stroke. Go to actuating labels. B0 is a sensor placed at 0 mm. B1 is also a sensor placed at 200 mm, that is end of the stroke. Okay. So here, very important observation is A0 is on. A0 is on means what? Means cylinder A is retracted. Retracted position. This is for your understanding purpose. Cylinder A0 on means cylinder A is retracted, like that. A1 is on means cylinder A is extended position. Okay, so like that you have to assume that for B0 on means cylinder B is retracted position, B1 on means cylinder B is extended position. And there are two solenoids here. Solenoid Y1 is for cylinder, means direction control valve 1. Solenoid 2 to control the direction control valve 2. Okay, Y1, Y2. So in this circuit, two solenoids are there, four sensors are there. Each cylinder has got two sensors. A0, A1 sensor for cylinder A, B0, B1 sensors for cylinder B. Okay. Now the question is, in which fashion we need to connect sensors and solenoids so that we'll get a sequence. So what are the sequence here? The required sequences. Required sequences A plus, B plus, A minus, B minus. Right? This is the sequence required. And here very important observation is, when solenoid Y1 is on, cylinder A will move forward. When solenoid Y1 is off, cylinder A will move backward, means retraction. Cylinder that is solenoid Y1 is on means cylinder A extension, Y1 is off means cylinder A retraction. So that is also one important observation. Like that, if Y2 solenoid is on, cylinder B will move forward. If Y2 solenoid is off, cylinder B will move backward or retraction. So now, to solve this kind of problems, there are different methods are there. I am going to explain one such method. Okay, so but you have to write down the facts here. So facts means, for example, write down if Y1 is on, if Y1 is on means what? Cylinder A extends. Okay, so like that you should have the facts with you, so that it is going to easy to solve this kind of problem, sequencing problems. Okay, to solve this kind of problems, there are two steps are there. So I'm going to explain here. Say there is a cylinder, that is there are sequence. What is the sequence here? A plus, right? A plus, B plus, A minus and B minus. Okay. Now, actually, there are two steps. So step one is signal flow diagram. Signal flow diagram. This helps in identifying the sensor sequence. Okay. Observe carefully here. If, see, this is one cycle, A plus B plus A minus B minus is a one cycle. Which is the end of the cycle? B minus is the end of the cycle. So end of the cycle should give a signal to start the new cycle, right? So end of the cycle is B minus. B minus means retraction of cylinder B. So retraction of cylinder B means, sensor B0 is going to on. Listen carefully. If sensor B is retracted, so B0 sensor is going to on. That means B0 sensor should give a signal to repeat the cycle, that is A plus. Okay, so you have to Okay, if B minus is completed, the sensor going to on, it is so now the sensor which is on when B minus is completed, that is B0. Okay, so this is important. Next is so what is the sequence after B minus? A plus should happen, right? So if A plus is completed, which sensor is going to on? Let me draw this completely so that repeatedly I don't have to take it. So when A plus is completed, A1 sensor is going to on. Okay, so that you need to so this is A plus means A1 sensor is going to on. Next is B plus. When B plus is completed, which sensor is going to on? That is B1. So this one is supposed to be here and this one is B1. A minus is completed means that is A0. So we have completed step 1, that is signal flow diagram. Next is step 2 is IO matrix. IO matrix means input output matrix. So here IO means input output, right? So here input is sensors, right? So from signal flow diagram you will get the sequence of sensor like B0, A1, B1, A0, right? I'll write it. A1, sorry, this is B0, okay, B0, next A1, B1, A0. So for this sequence we constructed the signal flow diagram. So what is the sequence? You have to write it again. A plus, B plus, A minus, B minus. Now for A plus to happen, when will cylinder A extend? When will cylinder A extend? When solid Y1 is on. So that you have to write Y1 on, like Y1, this is Y2, okay, Y1 on, Y2 on, Y1 off, and this one Y2 off. Okay. this is a matrix. So each line is one instruction. That means B0 should be connected to Y1 on, like that. Okay. So this is a solution, but first line should start with our command signal, that is S1. S1 means start switch. So how to read the matrix? S1 is connected to B0 and B0 should be connected to Y1. Okay, like that. B plus should be connected to Y2. Like that. B1 if B1 is on, Y1 solenoid should be off. That means normally close contact should be used, like that. Okay, so this matrix is a solution. Based upon this matrix, I am going to construct the relay circuit. So we'll take power supply, that is 24 volts, and 0, that is ground. Next is we'll take one switch, that is called S1. Okay, so read the matrix here. S1 is connected to B0 and B0 should be connected to Y1 on. Right. So here we can also write K1 relay, K2, K3, K4. So K1 is a relay, K2 is a relay, K3 and K4 are relays. Okay. So now the matrix reading is S1 is connected to B0 and B0 is connected to K1 relay. And K1 relay should be connected to Y1. On means normally open contact, off means normally close contact, you should take it. So here S1, read the matrix, S1 is connected to B0. So you take a normally open switch and double click on it. Here B0 is, you have to type it B0 here. See here, it is linked. So both are connected in series. That is what the matrix is indicating to us. S1 is connected to B0 and B0 should be connected to K1. This is K1. Okay. Fine. So in the matrix, that is Y1 on. So here we should use latching concept or signal storage concept. Otherwise what happens here, spring is there, right? So cylinder will go back. So should not go back, right? So for that, latching circuit means we'll have one more parallel contact of K1 parallel to the switch. This is K1. Okay, so this is the logic, means sorry, this is the vertical column, means first column is the solution, that means first column we have completed. Still Y1 is not connected, right? So K1, see, S1 is connected to B0, B0 connected to K1, K1 should be connected to Y1. So you take normally open contact and there is a solenoid valve and this is Y1. And it is connected to main supply. This is also K1. So line 1 is completed. Now next line 2. So A1 is connected to, A1 is a sensor, A1 is connected to K2 and K2 should be connected to Y2. This is A1. A1 is connected to K2, and K2 should be connected to Y2. So here there is a solenoid and there is a contact, that is K2. This is Y2 and this is K2. Okay, so line 2 is completed. Next line 3, column 3, B1 is connected to K3. This is B1 is connected to K3. B1 is connected to K3 and K3 should switch off Y1. Switch off Y1 means negate. That means go to Y1, you take normally close contact of K3 . See, normally close contact of K3. Next is A0 should be connected to K4. Double click on it. A0 should be connected to K4. K4 and K4 should switch off Y2. So go to Y2 and take K4, normally close contact because it is going to switch off. K4 okay. So this is what the circuit is, and the thing is that here even K2 also latching is required, otherwise cylinder means latching concept is required. This is K2. See, signal storage latching means if K2 coil is there, here also K2 contact will be there. So here also K1 contact, K1 coil. So that is what it is. So this is completed, but the concept here is it is going to oscillate because means otherwise you just make it common. Okay, that means for all the lines you just add a latching concept. and latching means if K3 is here, here is also K3. K4. Okay. So this is the solution. Let us go back and check for simulation. A plus, B plus is not happening. Why? Because some electrical connections is problem actually. Solenoid K2 is on. Actually this is supposed to be on. If K2 is on, this is closing. K2 is on. Okay. The last line, latching concept is not required. See, this is one cycle. Last cycle, see what is the last process? B minus. B minus means K4. When K4 is on, it should reset K1 and K2 and K3. So that is why what we can do is we can reset, means by using normally close contact. Or do one thing, it's like I have a common circuit here. That means all the 4 relays you can have a latching concept. See here, all 4 will have, so that it is easy for you to remember. But the concept is K2, see K2 should start, K2 should start only if K1 is on. K1 means A plus, right? Like that it is, I am creating some dependency so that sequence will not miss. This is K2. That means K3 is on only if K2 is on. Like that, this is K3. This is K3. When K4 is on, it should reset K1 so that K2 is also off, K3 is also off, K4 is also off. So which is the last process? K4. K4 should reset K1. This is K4. If K1 is on, K2 will be off because this will be open. So it is in sequences are there. Let us go to the simulation. When you operate S1 once, so I am reducing the speed here with a throttle valve. Observe S1, A plus, B plus, A minus, B minus. if you want still slower speed, A plus, B plus, A minus, B minus. Okay, so this is how you can by using these two steps you can solve this kind of sequencing circuits. I will zoom this one so that you can focus on here. So I hope you have understood this circuit development. Okay, so extension part is like PLC programming, PLC ladder logic development is also easy based upon this relay circuits. Okay, we can do that also, and that means fine. I hope, no, what I'll do is same in the same sheet. If I do the PLC program here, variables will be overlap. Okay, I should use same y1 y2 sensors, so this will be overlap. So that is why what I'll do is I will take a new file. Hydraulic circuit is same. Okay, first of all I'm going to save this. Sorry, this is here sequencing A plus, B plus, A minus, B minus. It is saved, and I'm going to save as one more file. This is PLC. I'm going to close this and then open hydraulics again. Go to file, open where it is saved. Like PLC and take it. So since I'm doing through PLC, I'm going to delete this. So I will take okay, this is the hydraulic circuit. I'm making space here. So if you're working with PLC, then you have to go for easy port, OPC, rotate by 180 degree and take output module, rotate by 180 degree. And here output is only two, that is solenoids, right? I'm going to take two solenoid, that is y1 and y2. y1 I'll give it to 0, and y3 you can give it to bit number 3. Okay. And PLC generates 24 volts, so you have to connect it to 0 so that circuit is completed. This is y1, this is y2, and I'm going to connect a switch, start switch. So in this problem statement, actually there are 5 inputs: S1, A0, A1, B0, B1. So total 5 inputs are there, 2 outputs are there. So S1 I'll connect it to this is S1 and connect it to 0th bit. Next is sensors. This is A0. A0 is connected to bit number 1, like that. 4 sensors are there. Bit number 3 I'm connecting to this is A1. So this is B0. This is B1. So S1 is connected to 0th bit, and A0 is connected to 1. A1 is connected, so here some overlap is there, just you avoid it. A1 is connected to bit number 2. A1 is connected to, A0 is connected, A0 is connected, A1 is connected to bit number 3. A0 is connected to bit number 1. 1 minute, here some confusion is there, that means I'll put this one. This is okay. A0 is connected to bit number 1, A1 is connected to bit number 2, B0 is connected to bit number 3, B1 is connected to bit number 4. Okay, and go to option easy, that is OPC, enable OPC. Okay, first of all you should open start EZOPC. You have to start first. Okay, so this is our input and output wiring diagram. Based upon this, I'm going to write the PLC logic, that is open Codesys. So what is the first step? First close the previous one and take a new one. Take 3S Codesys controller. Click on OK. Build the program. So very step is go to File, Save, and create a new folder every time. So this is sequence, that is A plus, B plus, A minus, B minus. So here I am going to save it as sequence A plus, B plus, A minus, and B minus. So first you have to save this, and now I'm going to write the PLC. It's very simple actually. If you have a relay logic, then it is very simple to write it. Okay. Fine. One minute. Actually, I'm based upon the relay circuit, I can draw the PLC ladder logic. Okay. So please refer to relay logic. Please take a reference of relay logic. Then you can easily draw the PLC logic. Okay. So start button. See here, start button is connected to which bit? Bit number 0. Right. So first you take an input. Say EB0. EB0. Enter. Declare it as a global variable and type is byte. One byte will have 8 bits, right? So even you can see 8 bits are there. It means 1 byte. Take output EB0, again global variable, type is boolean, type is byte. Okay, but now you start numbering, that is EB0 dot 0 is nothing but start or S1. So right click on the rung and put a comment. So in the comment you can type EB0 dot 0 is equal to S1, right? Like that. EB0.1 is equal to A0, like etc. So that is very important. So this is nothing but start, that is S1. Okay, S1. If S1 is operated, what should happen? What is the, according to the matrix, according to the matrix you can draw S1 is connected to B0, that is in series. B0, see B0 where it is connected, B0 is connected to EB 0.3. So here EB 0.3. If both are on, we are going to see here. Here K means you can say okay. Directly you can connect it here Y1, right? Y1 is a solenoid. Y1 solenoid means 0th bit we are connected. That means AB0. It is correct. AB 0.0. Okay. I will write it here in the comment section. So EB 0.2 is equal to A1, like that. EB 0.2 is nothing but B0, EB 0.3 is equal to B1, right? So according to the matrix, B0 should be connected to Y1. B0 means here address is B0 address is 0.2. See here. 1 minute. Here 0, 1, 2. Yeah, this is 2 actually. This is 3. 0.3. Yeah, here mistake is there. This is 0.3. Okay. Fine. So this is 0.3. That means according to the matrix I am going to construct S1 is connected to B0. B0 should be connected to Y1. This is Y1. So like that, in the same fashion, AB 0.0 is y1 and AB 0.3. See here, I have corrected to 3. AB 0.3 is equal to y2, right? So this is y1. If both are on, it should be on, and it should have a latching concept. For you to simplify, what I can take is, I will take K1 only. K1 is a dummy variable here, means internal relay. See, or bit memory can take it as. See here, K1. I will rename that is capital K. So this is capital K. It is case sensitive. So K1, I'm latching it. Okay. Next is you take a new network, second line. A1 is connected to K2. Sorry. What is the address of A1? A1 is EB0.2. So EB0.2 should be connected to K2. So take a coil and name it as K2. Okay, see here, K2 is defined as Boolean. Next line, B1 is connected to K3. B1 is connected to K3. And you should also do latching for every circuit. Latching means if K2 is here, here also K2. Right? And K1 should be on only with the condition of K2 should be on only after K1. So I will create a dependency here. First K1 will be on, next K2 will be on only if K1 is on. So I am creating a dependency here. B1 is connected to K3. B1 means what is the address? B1 is 0.3. Again here mistake is there. 0.1, 0.2, 0.3, here 0.4. So 0.4 is EB 0.4, EB 0.4, B1 means EB 0.4 should be connected to K3. But K3 should be on with the condition of K2. Correct, I am creating dependency here. And latching is required for this also. Latching is common. Latching means K3 is here, means here also K3. Okay, so last line is A0 is connected to K4. A0 means what is the address? EB 0.1. Take a new network here. EB 0.1, EB 0.1. So again latching concept is used, and take K4. Again K4 should be on only if K3 is on. So this is K3, right? Okay, for the last contact latching is not required, but if you maintain it is not a problem. Okay, so last relay should reset the first relay. So I am going to have normally close contact of K4. Okay. At last, what does the matrix says that when K1 is on, Y1 is on. K1 is on, see here, when K1 is on, Y1 is on, sorry, it's here Y1 I cannot directly write. Y1 means address what? AB 0.0, right? There is another condition, that is if K1 is on, Y1 is on. When K1 is off, when K3 is on. So K3 negate, we have to take it. This is K3. Okay, last line. For Y2, when Y2 is on, when K2 is on. When K4 is on, Y2 is off. On means open contact. So K2, K4 I should take it. This is K2 and this is K4. And for address Y2, AB 0.3. Okay, this is the program. So before downloading it, what is the step? First you have to create the symbol files. For that, go to resources, workspace, symbol file, symbol configuration, check both the checkbox, click on configure symbol files and deselect everything, click on OK, go to project, clean all. Now again workspace, click on it, symbol configuration, both tick mark, then select everything, click on OK, then go to project, rebuild all. Okay, now before downloading, open the communication. Communication is nothing but go to start, Codesys. You have to take Codesys SP PLC win, that is virtual PLC. Switch on. So your IP address now it is changed. 127.0.0.1 port is 1200. So but go to online here, communication parameter. In my PLC now address is different, so I need to remove. So what is the IP address? Windows tab, if you type, this is the 127.0.0.1. So take a new one. There is a TCP IP is there, 3S TCP driver, so take on that. So here 127.0.0.1, enter. Okay, and click on OK. Now go to online, login. Login means you are downloading the program to the virtual PLC. Yes. Again go to online, make sure that you are in run mode. Okay, so we are in run mode. But in FluidSim there is some pending is there. That means, so you have to double click on this one. So we are not defined that this is the AB module, this is the EB module. So double click on this, browse, Codesys. This is AB0, that means output module. Just double click on it, browse, Codesys. You have to search for EB0. Okay, fine. Now go to the play button, means start simulation. I'm adjusting the screen here. So here there's a start button, but okay, the thing is that one minute. Otherwise, this I'll keep it at the top and this at the bottom. Fine. Actually, it is working. The thing is that it's not coming onto the single screen. See here, I'm going to press start, but actually there is no relay circuit. It is working with PLC logic. Actually, it is extended, but second cylinder should start. B0, that is A1. When A1 is on, A1 addresses, it is 0.2. Let me check. Now K2 is on. K4, here we made a mistake here, right? So K4 should be normally closed. That is the reason. We made one mistake. Again, you have to download the program, run. See here, see there is no see there is no relay circuit. It's completely working with PLC logic. See here, what is the condition? See right now K1 is off, right? So if I press start, cylinder A is extended, cylinder B, that is A minus now, next last is B minus. I will repeat once again. A plus, B plus, A minus, B minus. Okay, so this is what the complete simulation of sequencing of two cylinders, A plus, B plus, A minus, B minus. So if you have any questions, put in the comment section, or we will have a discussion in the classroom. Thank you everyone.